Hello, everyone. Hello, hello. Welcome. Good to see a room full of founders here in the Google campus. Nice to see you today. I think it's the second or third time we're doing this with you guys. Yeah, so really happy to host again the Carbon13 crowd and to hear all the cool demos that you guys have prepared. My name is Amelia. I'm part of Google Cloud, and as some of you know, we have a pretty cool startup program. How many of you have been working already on cloud or are developing with Vertex AI and one? Okay, oh, there's two. So good, there's a place, three. Okay, it's coming up, but they're a bit shy. So Google Cloud for startups really allows you to fully develop and deploy in Google Cloud. We have over 300,000 credits. You're obviously using a lot of models already, so Google Cloud allows you to have an open market. You can work on OpenAI, Anthropic, etc. And also allows you to have a connection with a developer who actually allows you to get into Vertex and Google Earth Engine and all the other cool climate-specific tools that Google has developed. So any of you are interested in that, feel free to reach out. I'll be here throughout the day with you in the group. And yeah, looking forward to hear all the cool demos today. Welcome. And I think we'll be demoing until 3:30 when we have a snack, pause, and a break. And then a networking event this evening also in our offices. Thank you. I'll hand it over to you.
Okay. Yeah. Thank you, Amelia. It's really great to be back at Google for the third time already. This is our fourth kickoff, and we've done 3 of them here. I'm Simon. I'm country lead Germany at Carbon13, and let me start like that. Donald Trump once said, "Climate change is a hoax. The only thing he's ever acknowledged as real is his spray tan, and even that fools nobody." Okay. Trump has called global warming a hoax more times than he's filed for bankruptcy, and that's saying something. Because at this point, the only thing still rising faster than sea levels is his golf course membership fees. Not great either. Last one. Trump reportedly loved coal so much he wanted to bring it back beautiful and clean. Clean coal. That's like saying you're on a diet, but only eating artisanal cheeseburgers. It's still a cheeseburger, Don. Okay, we can cross that off the list. And with that, I promise you, you won't hear the name of this lunatic from the other side of the water again. And you will hear and see no more artificial stuff. So AI-generated jokes on Donald Trump. That wasn't me. I would never tell so bad jokes. That was AI. But we're here because we're all human. And this gathering here is a very human gathering, because what we celebrate today is the ceremonial closing of Berlin Cohort 4 and Cambridge Cohort 8. But we also celebrate the very human ability of community building, of collaboration. And I don't mean collaboration by threatening others or intimidating or humiliating them. I mean collaboration based on inspiring others, exciting others, and moving others. And that is what I hope is happening today, but also in the Carbon13 community. And I want to discuss and talk a little bit about what the community looks like. This is one of 2 slides I want to show you. So we had now more than 10,000 applications for venture builder programs. So when you can do the math, 4 and 8 means we are now closing the 12th program run. We also had 5 accelerator programs, so that makes in total 17 that we did. And we now have had more than 1,400 participants in our program. More than 300 ventures were born in the program. And we've now, since December, we've hit the 100 mark. We've now invested in more than 100 startups. But there is more community that is reflected here, more than just reflected here on the slides, because We are working with more than 400 domain experts in our network. They support the teams on demand. Some of them are here today, and be assured that you are much appreciated and that your work is. We're working with more than 10 entrepreneurs in residence, experienced founders who work with the teams and are their sparring partners and critical friends, especially in the second phase and the third phase of the program. We have impact experts. So they help the teams to get their numbers straight and to really understand what the additionality looks like and what needs to happen so that their impact is real impact in the end. They work on their carbon cases, as we call it, but it's way more than just carbon. And we have, and I don't want to forget that, we also have a storyteller in residence, Paul Bourne. There he's sitting. And with you, Paul, I want to use you as the segue to a quick look back, a retrospective, and talk about the very first day of the program. Because I think all you founders, Paul is connected very much to this first day of the program. Because Paul is doing some icebreaker challenges. You have to imagine in the beginning, we have 80 people from science, tech, and business. And there are 80 strangers. And today, I hope they're not strangers anymore, but you found co-founders, you found advisors, and you might have found friends in the cohorts. At least this would be nice because that's what a community is like, right? But let's go back to the first day. So imagine 80 people in the room, a bit like that here. And then there was one activity that kind of resonates with me very much and that I have to think of sometimes, which is the following. It's a game. So each of you, you don't have to play it, just imagine it. Each of you is picking one person. Don't say it out loud, you pick one. And then in the first round, you try to get as close as possible to that person in a respectful manner, with a respectful distance. Everyone's rocking around and they try to get as close and remain as close to that first person. Second round, you pick another person and you remember the first person. Another person, don't say it out loud. And in the second round, you try to be as far as possible away from the second person. And I think you can all imagine what the third round is like. So in the third round, you remember your person one and your person two, and then simultaneously, in parallel, you try to be as close to the first person as possible and as far away from the second person as possible. But everyone is moving around. And there's like a bottom line to this activity, which is focus and awareness. Because you have to focus on the person one, but you also have to be aware of what's going on in the room. And this, I think, is kind of a beautiful analogy, maybe to life, definitely to the climate tech and to the startup sector. A, is good to know who to be close to and who to be as far away as possible from. And B, it's good to know your focus, right? But still be aware of what's going on. And we as Carbon13, we are aware that there are multiple crises in the world. We are aware that probably the biggest threat for the climate crisis, for the climate, is right-wing populism, because they destroy everything that we've built in the last years. We are also aware that, as former Chancellor Willy Brandt puts it very beautifully, without peace, everything is nothing. But our focus is something else. We focus on building and backing ventures addressing Earth's critical life support systems. And there's much more needed in the space. Politics, activism, non-profits, but that's not our focus. So we try to be aware, but we focus very much on what we can do best. And again, backing and building ventures addressing Earth's critical life support system. And you, all the teams here, you do the same. You are aware of the fact that the willingness to pay for sustainability, so the green premium, is very little. So you focus, or you are aware that you shouldn't sell sustainability. That's not a selling point. You sell better, faster, more efficient solutions, maybe cheaper solutions even. But your focus is something else. What gets you up every day is doing something for the climate, is changing a not satisfying baseline scenario for the good, is working on your additionality and create real impact in the future. I'm aware that I'm speaking for almost 10 minutes now, and that's why I want to focus on the pitches now. But first of all, please give a warm round of applause to the whole community and to yourselves. It's great that you be here. I forgot the second slide, but maybe that was a good cliffhanger, and I have your attention. This is the very first day, or probably day 3. So this is cohort 8 and cohort 4 in the first in-person block in Cambridge and in Berlin. And we had terrible weather in Berlin, but I think Cambridge is indoor, so I think they had even worse weather. Right. So before we start the pitches, I want to tell you what's going to happen. We have 4 pitches in the first round, then a break. Then we have 5 pitches, then a break. Then we have a keynote by Pina Schloms, who is here somewhere. If not, she will arrive later. Pina is a sustainable lead at Siemens and also a thought leader for industrial AI. And in the end, of course, we have networking. Last important information, after every pitch, you have the chance to ask questions to the teams. So please, when anything isn't clear, ask a question and understand the solution better. We have 5 minutes for a pitch and then about 5 minutes for the Q&A. So please make the most out of it. And without any further ado, I would now transition to the first pitch. The first pitch is coming from MOGLI, and MOGLI is a team of 2, Darius and Alijan. And I always, when I think of you, you were never the loudspeakers in the cohort. You were never like bragging about your solutions up front. You were building them kind of in your room, and every time you were pitching your improvements and your new kind of version, I was super excited to see what you've built in the meantime, because there was always a lot building going on in the meantime. And MOGLI is working on speeding up the energy transition. And when you think about energy transition, you think maybe about hydrogen, you think about the hard-to-abate sectors, you think about industrial processes. And these are all very good questions, but sometimes the problem isn't that, but the problem is sometimes just data in silos that is not really communicating well with each other. And that, I think, is all I want to say now, because you can definitely enlighten us what you're doing to speed up the energy transition. And please give a warm round of applause for Darius. And Alijan.
All right, thank you very much, Simon. You can hear us, right? Oh, great, perfect. All right, so we are Alijan and Darius. We are the co-founding team of MOGLI, and we are on a mission to accelerate the energy transition with AI-powered automation. The global skilled labor shortage is considered to be one of the biggest operational barriers to achieving our energy transition targets. But at the same time, scarce energy professionals, such as engineers, project managers, are stuck in operational overhead. And this is estimated to cost the industry more than 100 billion euros every single year. But to make it more tangible, I would like to introduce you to Janet, who is a project manager at one of our pilot customers, Repower Solution. They are a front runner for renewable energy development in the commercial and industrial space, as you can see on the right side. And in his daily work, Janet needs to coordinate multiple projects and stakeholders at the same time. He needs to continuously generate and analyze various types of documents, and all of that within a scattered system landscape. And all of this operational overhead that he currently can't influence is significantly slowing down the project execution. And this is exactly why we are building MOGLI, an AI-powered energy operations platform fully integrated into the existing system landscape of renewable energy companies that enables project managers like Janar to streamline all of their projects within one centralized platform. With MOGLI, project managers are able to access the full company knowledge at their fingertips, retrieve any kind of project-related information via a simple chat interface, and automate repetitive time-consuming processes, such as the generation of documents. In the end, this results in a win-win-win situation. So for project managers like Jana, we are significantly reducing their operational overhead so that they can focus on what they're best at. Companies like Repower Solution can realize more renewable projects with the same resources. And in the end, for all of us, it means a significant acceleration of the energy transition.
Oh, I'm pretty sure you all heard of artificial intelligence before. Because large language models have made intelligence widely accessible. But intelligence without context is like a plane without GPS. It's powerful, but unlikely to reach its destination. So the real value lies in combining AI with deep industry context. And that's why we're building the context layer for energy. Energy projects run across dozens of disconnected systems. These are software tools, databases. Critical knowledge is fragmented. MOGLI integrates directly into these systems, unifies project data, encodes processes and regulatory logic. On top of that, we're building an application layer where the system doesn't just read data, it can generate documents, prepare grid applications, and coordinate workflows across tools. Of course, every action is transparent and auditable. MOGLI continuously learns from outcomes, corrections, new data, becoming more accurate and more valuable over time. So renewable energy developers sit at the center of a highly interlinked ecosystem. Every project needs to be coordinated between installers, grid operators, and many more. As we integrate into these workflows, we don't just automate tasks, we learn patterns. And that accumulated intelligence becomes our moat. As we expand this context layer, it's only natural that we'll move into adjacent segments, because the same intelligence that powers developers can empower installers, assist investor decisions, and optimize grid operations. So we start at the center and bridge the gap towards a fully interconnected energy ecosystem.
So we are capturing this market opportunity with strong domain and AI expertise within the founding team, and we are super thankful to be complemented by great advisors that bring in their superpowers as serial entrepreneurs, domain experts, and scientists. We have started working on MOGLI in Q2 of last year within a structured customer discovery approach. So we conducted more than 50 interviews with key players from the renewable energy ecosystem to basically identify recurring problem patterns. Since then, we have validated our solution on multiple conferences. We have signed 4 LOIs on 3 pilot projects. We have furthermore won 2 of the most renowned German startup grants, secured angel investor commitments, and last but not least, or most importantly, we have proven the real value of our solution with a fully functioning prototype in pilot projects. For the next 12 months ahead, we are planning with ambitious but realistic goals and a clear go-to-market strategy. So we are currently preparing the official market launch with MOGLI with strong industry partners for April. And with a projected 20 to 30% monthly growth rate in our first year, we expect to end the year with 10 full rollout customers. And based on that traction, want to raise a 1.5 million pre-seed round. So we're happy if you join us on our journey to accelerate the energy transition with AI-powered automation. And yeah, thank you very much.
Thank you.
Thank you very much, Alican and Darius. Do we have questions in the room? Of course, in the very back. Oh, Marina Houseby, wonderful.
So 2 short questions, please. First of all, the so-called context layer. How do you store the information in this context layer? Is it a data file, or is it just an AI, a network, a neural network? And the second question would be, is your whole system, is it actually only made to operate energy producer, energy grid operator, whatever it is, or is it also made to design and construct?
Okay, I can take that question. So for the first question, the context layer, what we identified is a pattern of specific tools used by these companies. So it doesn't actually encode it in the network itself, the neural network itself, but it just takes these software tool APIs and creates a common ontology. So we let the AI know what these tools are, what they are capable of, and use that ontology to direct its actions. And the second one was about the grid operations, I suppose, right?
Maybe that's the value chain of the, maybe I can
go ahead.
start on that. So basically, we are currently fully focusing on the operational layer, right? So I mean, like you have site selection, then you have like planning phases, design phases, operations, and then maintenance. We are fully focusing on the operational layer, as we see there, one of the biggest levers of actually create efficiency increases, and also a big market gap currently.
The so-called context layer.
Uh-huh.
Is it also the material of limit generation? So it's the idea that
Yeah.
that's the idea.
Sorry, can you repeat again?
RAG, retrieval of right. Thank you.
Is it a record?
You have the data somewhere.
Yes, some of them, yes, some of them RAG. Some PDF documents are through RAG, retrieval augmented generation. The others are through API connections. So to give context about these tool calling, what different software come into place. This is like design software as well. Getting these and then learning how operations are effectively done, and then automating the whole workflow.
Thank you very much for the crisp pitch. I have one question. Do you want to go beyond workflow automation? So what's your long-term vision?
Yeah, long-term vision is so these, or would you like that? The renewable energy developers, they work with, they need to find investments, they need to coordinate workflows with grid operations. So when we, as time goes by, when we learn these patterns, how investment decisions are made, and what kind of data exchange between investors and these renewable energy developers can do, then we can also expand our ecosystem to these investors. Yeah. This is just one example, of course. The same thing goes for every other stakeholder in this ecosystem.
Yeah. Maybe just to quickly add, so basically the nature of how the energy ecosystem works is predestined for those kind of technologies, right? So you have along the value chain, metering operators, grid operators, utilities, and they're all basically interlinked in their actions until a project gets to the grid. So until we can consume a kilowatt hour of solar energy, a lot of different players are interconnected with document-heavy processes and data flows. And that's basically where we fit in the long run.
Thank you. Do we have a question in the live stream, Jag? We have time for one last question. My colleague Jag is observing the live stream, and hello to everyone joining us online.
Yes, so one question, what kind of pricing model do you have in mind?
Yeah, so I can take on that one. So basically we'll go to the market as a typical B2B SaaS solution. We'll have a flat platform fee and a user-dependent growth component. We're currently still evaluating whether we make it user-dependent or project-dependent, but basically the goal is to grow together with the customers. And yeah, that's it in a nutshell.
Thank you.
Okay, thank you. Thank you, Darius and Alijan.
Thank you.
So I think the next team is great example in many cases. But what I mean here is two. It's a great combination of commercial skills and technical skills. You will hear more about that. And that is something that we're looking for in the team building process, especially. And then B, it is this sector, one of the hard to abate sectors where you find very solid infrastructure and where people don't move away from how they do things easily, because everything is very expensive. And when you change tiny things, it has a lot of consequences. I'm talking about shipping. And that is a great example because
Not talking about shipping.
Oh.
You will talk about shipping.
We're KODNYX. KODNYX is okay. Forget everything what I just said. We stay in the energy sector. That would be like pitch karaoke when you speak about shipping. Okay, forget about that. I will come back later. You were nodding here in the first row, Rima. Okay. No, we're speaking about KODNYX. So let me kind of reboot. KODNYX, the first thing I remember, before you were even a team, were you, Andres, when you spoke about your idea for the first time. Andres was so full of drive and ambition, and there was so much fire in his eyes, and he spoke about electrical architecture and AC and DC, and I caught like half of it. I didn't understand it to the full extent, but it was enough to understand that there is a lot in there. And then when you found your team, Duigo and Christopher joining, it was amazing to see the team spirit that the three of you have. It's just wonderful to meet you every time. But let's get back to the topic, and please give an even warmer round of applause after I've messed up here to KODNYX.
Hello. Hello. Yes. Here we are. So not chipping. Okay. So hello, I am Andres from KODNYX. We are building software to redesign how electricity flows inside facilities. I'll be talking about alternating current and direct current, AC/DC. And no, it's not this AC/DC, but many people think about them right away. I'm actually talking about something else. There was an AC versus DC war, and that war still shapes how electricity moves today. So this is Tesla and Edison. 135 years ago, alternating current won that war. Why? Because it made sense for long distance transmission at the time. But today, in the modern world, inside every building, most of the things run in direct current. PVs, batteries, electric vehicles, everything what's electronics, motors in factories, everything runs in direct current. So we need to be converting from AC to DC back and forth many times. The consequence, we lose up to 35% of energy right there. Not because machines are inefficient, because the architecture is. Enter KODNYX. We are optimizing the electrical architecture. We model AC, DC, or hybrid compositions for every facility. We're comparing them economically as well. So this is not just drawing, this is a system level optimization where those savings are hiding. Now you may think, this is maybe too good to be true. How are you going to do it? This is a channel. We work with energy efficiency providers. Who are they? These are engineering firms, EPCs, energy consultants, the ones building the energy transition. What they do today is they offer to their customers pretty much upgrading the machines, installing renewables and storage, and integrating an energy management system. We now provide them with a 4-layer architecture. And these EEPs, they rely heavily on two things. One, how good the software they use is, and how much saving they can provide to their customers. And I know this because I was one of them for 15 years. So you see, that's me, one of them. So now with KODNYX, what we do is we empower even more these EEPs. The EEPs can provide a lot more savings, up to 35% extra saving on top of everything else to the facility. And the facility reduces the OPEX. That's the value chain. As I said before, too good to be true, maybe too theoretical. No, DC adoption is already underway all over the world. What's the issue? The knowledge to do this is severely fragmented and locked inside research facilities. So only a few players can do it. Even with those constraints, 2024, already 30 billion euros were spent in DC microgrids, not even hybrid, just DC microgrids. But it's not just the world, we're already doing it as well. This is our first pilot, Hartig in the south of Germany. We are creating a DC island within this factory. We're already reaching 15% of savings. Now we're looking into coupling with PV and storage. That's another 10% extra savings right there. And if this were, for example, all data centers in the world, we would be talking about 24 billion savings today, right away. But we're not stopping there. There are more pilots to come. We're talking to automotive, to logistics, the different industry, and every one of these facilities that we're talking to, they consume so much energy that the potential saving that they have is up to €1 million for each one of them a year. Now, just think about this. The electrification all over the world is accelerating. You have cost and policy pressure. You also have decarbonization mandates. Also, all data centers run 100% DC. So the market for this is huge. We're talking about more than €600 million globally, billions, sorry. And it's not just an economical impact. Look at our carbon case, 35% power saving, 55% material saving like copper, 85% less pressure on connection for the grid with the utilities. And what better team than this one? Right? So me and former EEP, we have Duigu over there. She structured over €2 billion in infrastructure investment. Christopher on her side, he built and scaled the AI optimization software for Flix, so multinational unicorn. And we have Dr. Tim Kuhlman, who's our advisor. He's one of the leading researchers in the world for industrial DC systems. So today we're raising an angel round as a bridge to pre-seed with Carbon13 and angels. We already secured 170,000. We still have 160 more to go with one main purpose, to keep proving customer value. And DC, it's not something new. It's a sleeping beauty. It's been around for more than 100 years. KODNYX is here to wake her up. We're not about changing or replacing AC. We're about redesigning the electric architecture for an electrified world. And as AC/DC put it, for those about to rock, in our case, for those about to rewire, we salute you. Thank you.
Thank you very much. And team, I owe you a drink. And this is going to haunt me in my dreams tonight. Do we have a question about KODNYX?
Is the expectation that you would have to change the capital stack inside the facility because you now need DC-DC converters and other DC-related equipment? Or would your software do it somehow else? How exactly do you consider deployment?
So what we do with the software is we design and provide the optimal setup, but we start by validating what's already there when it's a retrofit case. In a greenfield project, it's completely different. That's easier, right? But for a retrofit, what we can do is validate the existing infrastructure. You're going to have to work always on the protection because protection for DC is different from AC. The logic on how they move is different. That's why you need to redesign. You cannot just take a software that designs AC. But the outcome of the software, it's all the documentation to build it so that any electrician can deploy. And we're not pushing this as an extra thing for factories or for EEPs to do. Every year, this EEP, they have the pipeline with factories and facilities knocking on the door because they want to save energy. So this is just an extra layer that they're going to use when they provide the service.
Yeah, so the the up to 35% saving and up to 55% less copper, etc., that all sounds very impressive, but that's the up to numbers, right? Like what about the on average numbers for a typical customer?
So on energy saving, you reach about 20%. That's the average. But the more complex the facility, the higher the number, right? And we expect that number also to get higher because that depends on technology. As technology gets better, the numbers will get better as well. And the case for materials, that's very close to 50%. Actually, there's a more extreme case in Delft in the Netherlands. They save 75% of copper when deploying this.
And maybe just said the 35%, it's not like research and theoretic, but it's done in actual projects. So 35%, for example, one of them is in like, what is it, east of Munich, Schaltbau, for example. So it's actual numbers.
Thanks for the pitch. My question would be, so AC/DC, you said it's already a sleeping beauty. So maybe there's multiple solutions out there. So what is the current state of your competition? How did people do it before you existed?
Well, it's not a technical constraint. It's just a legacy and how things are being done always. Because DC has been around for a long time, and technically there's no constraint, but everything has been developed for AC. So, for example, you have AC equipment for every single number of voltage. For DC, you don't yet. Right? So it's only starting. So that's why you need to optimize according to different constraints. One of them being the hardware that exists, and that's where most of the players are working today. They're building new hardware, but what's missing is how to build it, how to put all the things together. That's locked inside research institutions today.
Whom are you addressing actually? Big industry complexes, big energy consumption companies? I think that the private households, they still will rely on AC, of course. So it will be kind of island solutions that are more energy efficient in the area of the island, but outside it's still the old AC structure. Makes sense in a way that the transportation layer already is on DC, of course, because it's less energy lost then.
That's a really good question. Thank you. We're not pushing DC. We are pushing in optimization, acknowledging that there's a lot of DC involved. Most of the future we know is going to be hybrid. It's not going to be DC. It took us 100 years to build the AC grid. We're not just going to change it right away. That means that most of the setup will be either a DC setup with small AC islands. For example, a data center is almost 100% DC. So you can create a DC setup and AC island for pieces of equipment, or the other way around. A non-automated factory can have an AC setup with DC islands, like what we're doing in our pilot today. It's not an automated factory. We identify the islands, and we optimize the whole setup according to that.
Maybe just a quick addition, and in this way you can also increase the energy capacity. So there are also other additional, like more like an upside, like just by switching to DC, you don't need to increase your solar PV capacity, but with this you're increasing. So that's also a soft solution for the grid congestion, which is also a big issue in these days.
Okay, wonderful. Thank you, Team KODNYX. And now we're talking about the shipping industry. So as I said, great combination of technical and commercial knowledge. And my other example, that's the one I didn't speak about, is when you have such a huge problem space, your task as a founder in the beginning to narrow down the problem. And yeah, the hashtag here is marine biofouling. And Julia, you're going to talk about that.
Exactly. Hi, I'm Julia. I'm the CEO of NEREIRA, and we're using smart surface technology to help decarbonize shipping. Your clothes, your phone, the banana you had for breakfast this morning, it all traveled by ship. We move more than 90% of our goods via the oceans at some point in their life cycle. Causes 1.2 gigatons of CO2 emissions every year. That's 3% of global greenhouse gas emissions. Now imagine cutting a significant chunk of this by solving one ancient problem, biofouling. Biofouling is the settlement of marine organisms on ship hulls. And a thin film of it, just 0.5 millimeters, can increase fuel consumption by up to 25%. In 1761, the Royal Navy covered HMS Alarm in copper sheets to protect her from speed-killing biofouling. And believe it or not, toxic copper is still our go-to anti-fouling ingredient. Only nowadays, we mix it into coatings and let it leach into the ocean. There is more eco-friendly solutions, but they lack mass adoption because they're expensive and they don't work for every vessel type. The worst thing about it, it doesn't even work reliably. Inspection data of 685 ships showed significant fouling despite their anti-fouling coatings. In one of our first industry interviews, someone wondered, how could we have put a rover on Mars, but we still can't keep a ship's hull clean without damaging the environment? That question stuck with us. And we realized Maybe it's not that biofouling can't be solved. Maybe we've been trying to solve two fundamentally different problems with one solution. Ships need drag reduction while sailing and biofouling prevention while idling. So what if we address those two challenges separately? The result is a dual mode approach, two weapons instead of one silver bullet. First, we engineer an ultra-smooth, biocide-free surface that reduces emissions and prevents biofouling under water flow. Second, during port stays and other idle periods, we activate the surface, triggering a chemical reaction that destroys biofilm and inhibits new settlement. This isn't just another coating. This is an anti-fouling system that adapts to how ships operate, sail efficiently, and protect from biofouling while idling. Our technology will allow us to reduce fuel cost of ships by an average of 20%. That amounts to up to 1 million euros per year for a large ship. Now, this is a massive technical challenge, but we are the right team to tackle it. Dr. Rima Darawish is a chemist with a PhD in nanomaterials, and I have over 20 years of experience in product development. In just 8 months, we've gone from the first idea to execution. We've done over 60 industry interviews with experts, partners, and potential customers. And this led us to sign an LOI with Hapag-Lloyd, one of the world's top 5 shipping companies. We've assembled a board of advisors bringing over 50 years of maritime and coatings experience, supporting us with knowledge and network access. We've secured investment from Carbon13, and we have a lab in Munich that is operational. We're on track for proof of concept within the next 12 to 18 months. We're raising 200,000 euros, which together with the Carbon13 investment, will allow us runway to proof of concept and positions us for grant funding. Now, this is not just a massive decarbonization opportunity. This is a 1.7 billion euro market. Now, I wouldn't usually quote from the Bible, but let me make an exception. Genesis 6:14 says, "So make yourself an ark and coat it with pitch inside and out." So at the times of the Great Flood, biofouling was obviously a big enough problem for God to specifically instruct Noah to coat his ark against it. It's taken a few thousand years, but we are finally here to solve it. Thank you.
Thank you, Julia and Rima. Do we have questions?
Thank you for the excellent pitch and great storytelling.
Thanks.
I'm here.
Thank you.
So it only can be done by 2 women, female founders, so thank you for that as well. I have a very simple question because I understood your topic very well because it was super well presented. Are you based in Munich? Did I understand that right?
Sorry?
Are you based in Munich?
Yes,
Is that right?
based in
Okay.
Munich. Well, Munich and Salzburg. So landlocked and very far from
Okay, so Hamburg would be a much better location.
Hamburg would be a much better
Okay,
location.
let's talk later.
Julia will pitch in Hamburg on the 12th of March.
Thank you.
If there's anyone interested in seeing Julia pitch again, join us at our Hamburg event. But now back to the questions.
So thank you for addressing this problem. What's the idea for the activation mechanism? What's the idea of how should it work?
Yeah, without going too much in detail, because we're talking about IP here, but it's going to be an external activation mechanism delivered by ROVs or underwater drones. So every ship is supposed to have their own robot. So the approach is consisting of the coating plus the activation mechanism.
So maybe I can add that during idling of the ship, that's the problem. And there's a lot of companies suffering with this. That's why they use robots to with the normal brushes to clean it up. For our technology, we don't need this. We already have a whole system which work in both cases when the ship is moving in the sea and when the ship is idling. So you don't need also to have the normal robotics brush cleaning.
Yeah, thank you very much. Very interesting topic. I'm just wondering if, so you say you're still moving on to a proof of concept.
Yes.
And how did you calculate this 20% on average saving per ship on the fuel if the proof of concept is not there yet?
Yeah, that's a very good question. So there is a lot of data out there on how much could be saved if we eliminated biofouling totally. There's a curve that goes up to 55%. So talking about 20% is actually quite a conservative average that we chose, saying that's the goal that we have to reach that.
Thanks. Yeah, great pitch. My question is about, would you deploy this for existing ships or is it for ones being manufactured?
No. So anti-fouling coatings is something that is reapplied every 5 years. A ship usually goes into dry dock every 5 years. So that is something that comes into place every 5 years. They change their system of anti-fouling.
Great pitch. How easy it is to enter into commercial relationship with the shipping companies, be it pilot or more sort of like scaling? And also on the competition, how competitive is this space? Are there companies that raise a lot and quite advanced?
Yes. So for entering the market, we thought it would be impossible. We don't have any connections there. We just started cold calling people, and we actually found a super supportive and very interested ecosystem. People were super ready to talk with us. So that was much more easy than we thought. And also talking to those shipping liners like TUI Cruises, Hapag-Lloyd, Maersk, we talked to all of them. And yeah, talking to Hapag-Lloyd and getting them to be interested in our technology was no problem at all. So we thought it would be much more difficult. It's said to be a conservative industry. It seems it's not so much. So from our point of view. Concerning the competitors, it's true. There's a lot of companies, coating companies out there, but we don't want to compete with them. We want to provide them with an additive so that they can use our technology on their coating systems. An anti-fouling coating, a shipping coating, is a very complex system of different coatings. It's 5 or 6 different components. So it's a very complex system. We're not planning to reproduce that from scratch. There is people out there who've done it, but we would like to have our technology as an additive to be added to those systems.
I can add a little point. So we have been invited in 2 conferences. And then there's a lot of companies were like trying to solve this problem. So even some of them were competitor, but they were like trying to have more sustainable solution because there's coming regulation and they should find a way to solve this problem.
Hi, I actually have a question regarding how do you came to the idea of having a drone underwater? Because it's really like out of the box thinking, like, why would you do that? And I'd be interested in that process, actually.
Yeah, I don't want to take the merits of somebody else. It's actually something that is already being done. So underwater drones for inspection, to see the state of a ship, robots, all of this already exists in shipping. So it's not us that kind of invented this. We just steal from somebody else.
Hey, thank you very much. In my younger days, I was a radio host, and I was once interviewing a comedian, and this comedian was having lunch. And there's one golden rule, and now you understand why I'm telling you the story. Never give away your microphone. And I did that back then, and it was the worst interview because the comedian was having lunch and kind of interviewing me. So I did the same mistake again, but I think this time it makes a lot more sense. So next team, we are talking about something else now. We're coming from water to land, and it is the case at the moment that 2 billion hectares of land are degraded. And so the soil is malfunctioning when you want to put it like that. And that means that we turn, by not taking care of the soil or by destroying it, we turn carbon sinks into net emitters. And oftentimes the problem here, or the transition is slowed down by a data bottleneck. And Akila and Ekaterina are talking more about that. Please give it.
Thank you. Thank you, Simon. Can you all hear me? Yeah? Hi, everybody. We are Soil Next. We are here to regenerate soils 1 hectare at a time. Essentially, all life depends upon soil, said Dr. Charles E. Kellogg. There is no life without soils and no soils without life. But let me introduce you to our pilot partner and a regenerative farmer himself, Dan, who said something else completely. He said he's not sure if there is life in his soils. And not just Dan, unfortunately, greater than 500 million farmers are working with soils that lost productivity due to loss of soil biology. But the good news, it's not all grim. Soils can be revived. They're super robust. But what we do is we have to look into the soil biology and start with the right soil test. But that didn't make Dan happy. He's still tormented because there are too many soil biology tests, he said. He also said that he has very narrow windows between the seasons to make management decisions for his next crop and next growing season. And most soil tests are expensive, they take too long to provide the results, and are providing just numbers or uninterpreted data, kind of leaving Dan where he was before doing the test even. And that's exactly what we want to address. I'm Akila, the co-founder and CEO of Soil Next. I'm responsible for all things business and growth. I'm a second-time founder, and I have experience working with farmers in India that actually ignited my journey onto this path.
And I'm Kati, the CTO. I'm responsible for all things AI. I'm a data scientist by vocation and soil scientist by passion. And I'm also a guardian of a small forest in Portugal, which is a bit blocked here. So how does it all work? There are 3 pillars. First, we generate interpreted soil health reports. By combining them with the context of the grower, we provide a treatment plan. And if that treatment plan demands for green inputs, the customer can go and buy them on our marketplace.
No.
Right. So then send us a few samples. We scan them, and this is just 2 tiny snippets of 2 of them. Can you tell which one is healthier? Even I can't, and I'm an expert. But our AI can. It zooms in even further. It annotates every single instance it can find, and it characterizes them. Then it combines thousands of data points into very clear reports. And now we can see actually the first sample was healthier. It's not perfect. It's still in the amber zone, but it's definitely better than the other one. So Dan can go to his dashboard, look at the sample results. Beyond the overall metrics, he can look into more details, see the images themselves, get the summary, and most importantly, he gets a recommendation how to improve these soils even further. In this case, our recommendation is to use biologically rich compost tea to improve the soils further, which he can purchase on our marketplace, the first marketplace for green inputs in Europe.
But that's also where our competitive advantage lies. Yes, we're the first integrated marketplace in the European zone, but we're also able to test and provide interpreted results in under 48 hours, thanks to our high-throughput robotic microscopy, which allows us to scan a sample in under 30 minutes. We are also affordable. I know a lot of you don't like listening to this word in this room, but that allows us to have more accessibility and retention and repeat testing with our audience, increasing our CLV at least conservatively by 6 times. And we provide robust data because our AI removes all the human biases and errors, and we are testing larger data volumes per sample. And our moat lies in all 3: our test approach, our AI on how it does it, and our business model of how we take it to the market and talk to the customers. How has our journey been so far? Working in this industry, we've been tracking everything seasonally, So by autumn 2025, we had 3 pilot partners and our MVP ready. And by winter, we were able to convert a few of them into paid pilot partners and onboarded new paid pilot partners, getting us early revenues. And we got our first investment thanks to Carbon13, and we've been incorporated in the Netherlands. That's where we are. Oh, and as of 30 minutes ago, we're the official MRB partners for a major regenerative festival in Europe called 10 Lives Festival. Just came in. Thank you. And we have really big plans for the future. So by autumn, we want to commercialize our diagnostic and marketplace products. And by spring, initiate international market expansion, and off we go. But our journey has only begun. And to make this an actuality, we are seeking to raise 100K on top of what we've already gotten. And how are we going to get these revenues, right? Soil biology testing is a very relevant market for multiple different customer profiles. For the next 2 years, we are looking at 40% of our revenues from input providers who are going to list their products on our marketplace and have transaction charges, but also we are able to certify and their readiness and also validate their performance claims. Then we have 35% coming in from our agronomists and farmer associations, and the remainder from individual farmers. So that makes our projections look like a conservative 68,000 this year, but we scale quickly to 2.5, which is less than 5% of the market potential that we have. So join us on this journey to turn soils back into the carbon sinks that they were and regenerate them 1 hectare at a time. Here we are at Dan's farm after a technical demo, drinking their farm wines and eating their farm food and talking around a bonfire, which is the upside of working with farmers. So join us in regenerating not just Dan's, but all of the world's soils. And we are always happy to hear from you. Thank you so much.
All right. Questions for Aquila and Ekaterina?
I would be very interested, what range of size do you analyze visual by the AI? Do you only analyze insects, or is it down to size of microorganisms?
Yeah, all the soil food web networks, but our soil scientists.
Yeah, I can. Yeah, so we are focusing on microbiology. So the insects and the mites in the soil that's already meso, they are less likely to get under the microscopic slide. But tardigrades would be the maximum size, and then lower would be nematodes, fungi, protozoa, and bacteria, of course.
Thank
you. Yeah, sure.
Hello. Hi, thank you for the presentation. I just have a question. Is the diagnosis able to indicate whether there's unsustainable land practices underway as well? Because it's great to put an additive in the soil, but if it ends up just being another fertilizer, and we haven't actually addressed the underlying problem, yeah, I think it's an interesting.
Yeah, just one part, and maybe you take it over after that, is we actually ask for contextual information or metadata from farmers and also optimize our analysis and results to their goals. 2 farmers could have completely 2 different goals, so we're trying to keep that in mind. But how exactly we're going about it?
Yeah, so I think I can add also a very specific example. A neighboring farmer, I think, so what I want to say is that longitudinal approach with the context is the information that actually will tell us whether a practice is detrimental or not, regardless what we actually know in the literature potentially. So a farmer, neighboring farmer of mine, I tested their soils in autumn and actually looked pretty good. I was happy to report like, wow, it's decent soil we have. In March, I tested again and it looked much worse. I didn't know what happened. I asked, did you till? And he like, on his head, yeah, I tilled. So that was clear. He killed a lot of biology in his soil by just that destructive practice. So yeah, the answer is yes.
Very interesting proposition. A question on the products that you will be selling. So aside from the couple that you mentioned, what type of products are we talking about? Can the suppliers sell in bulk? And the other question, would your customers be only small farmer holders or big agri groups? And if it's agri groups, will it be bulk buying type of sale?
So, okay, the first question for the marketplace, we are at this point of time asking our vendors to fulfill their orders. So we are able to just give them visibility and also keeping ourselves low capex by not having to take a warehouse or make forecasts. And we are giving geographical visibility to where our pilots are at this point of time. Bulk sales are obviously encouraged because we take a transaction charge out of the transaction itself. But one criteria that we have is for wetted green regenerative inputs. So we want to keep compliant with regeneration and technically staying away from the icides like fungicides or pesticides. And the second part, it's not just farmers. At this point of time, one of our major customers is a biostimulant company, not as a lister on our marketplace, but we are validating their performance claims, where they say use our product and you're going to increase the fungi population. This is right under our alley. So the B2B validations and certifications of these products is where a major chunk of our revenues will be coming from, which also allows our positioning of our test itself to be rather affordable. Thank you.
Yeah, we all, you mentioned there are more than 500 million regenerative farmers out there.
Yeah.
Sounds like, enormous scaling potential. So how are you going to scale? What's your long-term vision?
Yeah, amazing question. Thank you. So for the next 6 months, we'll be working as a centralized lab to make our tech solely robust. And then for the 6 months following, we have partner labs, especially in the EU regions. We're talking to somebody in Italy. We have a partner lab in UK, almost finalized. And we are talking to somebody in Switzerland as well to actually increase our potential. And eventually a handheld device that would be compatible with phones so anyone can test anywhere and how many ever times they please.
Okay, wonderful.
Thank you so much.
Good to you, Now I was firm and look in the direction of the next presenter to not mess up again. But we're talking about another big problem now, which is the built environment. Most of you might know that the built environment is causing up to 40% of global emissions. And most of that is because the buildings in use consume a lot of energy. But there's still a good 10% of global emissions going back to demolition, extraction of materials, and construction itself. And the industry is stuck with emission-heavy materials and things like steel, cement, and bricks, but not any longer. Welcome, Paul, to the stage.
Hi, everyone. It's good to see you. So my name's Paul Radziwill. I'm co-founder of Composite Designers. We're looking to raise £450,000 for commercial launch. We start with the question, can construction be a carbon solution, not a carbon problem? And to answer that question, we've developed carbon negative bricks that turn buildings into carbon stores. So we have LOIs, we can match market prices, and we are scalable. So developers and contractors need sustainable construction materials. This is driven by regulation, and it's now becoming a commercial driver. Embodied carbon is now a measured, scored part of construction tenders, but sustainable solutions at the moment are either only marginally sustainable, or they're too expensive, or they're too disruptive to be able to scale to construction's requirements. On the other hand, we've developed carbon negative bricks and tiles made of biochar. They're as strong and robust as bricks, We match market prices. And the important thing is they're scalable because these can be manufactured in existing brick factories, and they can be installed with on-site with no retooling and no retraining. So, and they are 100% circular because they're made of biochar. In terms of our beachhead market, we are starting with brick slips. For the first couple of years, we'll be manufacturing these in-house and selling them direct to developers and contractors. But in terms of scalability, we're looking to sell the feedstock to manufacturers after we've proven the market, and we can leverage their scale of production and their sales and distribution channels. So in terms of the unit economics, with in-house production, we have a 37% production margin, and that's with fairly conservative volumes of about 250,000 brick slips a year. And once we phase in third-party manufacture, our production margins are going to be 81%. And the revenue in year 7 is £60 million, and that is, for context, less than the output of one large brick factory currently. And the numbers you can see here do not include our raise, so you can see the mechanics of our business model. So in terms of the market opportunity, it's a big market, so we need to be very, very careful about who we're targeting. And the UK is systemically undersupplied, and it's missing their home building targets. And the EU is, sustainability is more commercially involved. So we're targeting both the UK and the EU. It's a 300 to 400 million pound or euro serviceable market. But we're not just a niche player. Long term, we are going to be targeting global full-size bricks, because we see this as a platform for scalable decarbonisation in the built environment. So we have letters of intent from one of the largest UK construction firms and architects. As I said, we are manufacturing these brick slips in-house after Q2 this year, and we will be piloting industrial scale manufacture later on this year in Q3 with a commercial manufacturer. We have pre-seed funding from Carbon13 and grants from Innovate UK and the EU. I won't go too deeply into the competitive landscape because of time, but as I said before, most alternatives are either just not carbon negative, but just marginally more sustainable than the incumbents, or they're too high cost for construction, or they can't be scaled. And that's the space that we filled. In terms of our team, Frank, the technical co-founder, is not here at the moment. He is, his background is in aerospace material design, and he realized that the materials that he would develop for spacecraft that have to perform in extreme conditions, he can take that technology to construction and create these carbon composites that can perform in construction. I've worked in construction, the built environment and supply chain. I've scaled a number of organizations to high growth. And in the time that we've been together, we've created an ecosystem of experts and industry partners across supply, manufacture, and construction. So we're raising £450,000. We need to deliver our LOIs. We need to get certification and embed some partnerships with manufacturers. We're really excited to be doing this. We'd love you to join us. Please talk to me after this, maybe during this break, because I have to travel back to London a little bit later on today. Thank you very much.
Thank you, Paul. Are you ready for some questions?
Yeah.
Okay. Do we have questions in the room?
What's a brick slip? Oh, brick slip is like it's effectively a brick tile. So they look like bricks, especially when they're installed on walls, and they're used for residential and commercial cladding. So if you see a recently built brick wall, the chances are very high that they're actually brick slips, but they look like full-size bricks.
Klinkerstein is the German word.
It doesn't help here because Brett is Australian, but thank you very much.
Oh, sorry. What's your feedstock? Because there's a huge volume required. So do you have an infinite supply of feedstock for conversion?
For biochar, yes. So biochar is pretty plentiful. We're looking at a variety of feedstocks, wood, biochar, agricultural waste, and also other waste materials such as sewage sludge. So we're talking to 5 water companies in the UK who are really interested in pyrolyzing their sewage and using them as construction material.
Pyrolysis is fairly carbon negative.
It can be, well, what we're doing is heating up organic matter to lock in the carbon, so the carbon is not then released back into the carbon cycle. And pyrolysis effectively needs a bit of a kickstart, but after it reaches its pyrolyzing heat, it's self-sustaining, and it actually generates energy.
On that point, how expensive it is to produce biochar? I was of an opinion that, set aside global south, it is still quite expensive to produce. And then second question, who would be retiring CDR? I presume that process will generate CDRs, so carbon offsets.
Yes, okay.
Are you generating this revenue, or is this biochar producer?
Great questions. If I can answer the 2 questions separately. So yes, biochar is more expensive than sand and clay, but the production process of these does not use kilns. And each traditional brick is fired at over 1,000 degrees centigrade for 3 days. And it accounts for 30 to 35% of production costs. So our feedstock, the highest cost of our feedstock is offset by the higher cost of energy for producing traditional bricks. We are looking at cheaper feedstocks. That's why we're talking to water companies to look at pyrolyzing their waste. And we have some very, very clear cost price thresholds that we are looking to hit. We're very, very confident of that. There was something else that I wanted to tell you that I've forgotten now. Yes, the offsets, again, they can be, generally, they are taken by the pyrolyzers themselves. So we don't deal with carbon credits ourselves. We're quite happy with that.
To acknowledge our online users, I'd love to hear one. Oh, I'm sorry, I haven't seen that. Please go ahead.
Oh, it's just a quick one. I'm curious what the motivation of the sector is for change. Like, is there regulation coming in or something that's driving it?
Yes, so the regulation in Europe, in certain European countries, it's now legal. It's a legal requirement to look for low carbon materials for construction. So construction's been through a really interesting evolution where a few years ago, the focus was really on operational decarbonization, making buildings more efficient. Now, the focus is really on embodied carbon and reducing the emissions of the materials themselves.
So one quick one from the online users. Jack, do you have one?
Yes. Can this be reused for the construction of new buildings?
Are you talking about end of life and circularity?
Yes.
Yeah, absolutely. Again, because it's biochar and we use a bio binder, the circularity can be either this can be crushed and used as a soil enhancer, or we can reuse these and create new bricks and reuse them in construction. Thank you.
Thank you, Paul. Is it okay if we move the next one to the break? Because we have a break now. Thank you very much, Paul. We take 15 minutes and please find some refreshments where you've seen it before, probably. And yeah, please be back in time, but I'm going to push you back in if you don't.
My niece. Should we test the
recycling today isn't working. Of the 1.5 trillion pounds we spend per year on waste management, we spend 70 billion just on recycling what we throw away at home. Yet we recover only a tiny share of material that goes through the process. And the reason for that is that recycling today is a capital and labor intensive, heavy industrial activity that's seen little change or improvement for decades and happens in large, centralized and inflexible facilities. But we have a different vision for the future, one where we move away from the concept of waste entirely and to the concept of circular material flows. Material is used in goods and products. It's collected in a simple single collection from homes and businesses, taken to a local hub powered by TERASORT, where it's intelligently processed into the single materials it needs to be taken directly back to manufacturing sites for remanufacture into new goods and new products that can go round the circular loop again and again, truly sustainably. And we're enabling this vision by building the first low-cost, fully robotic, modular alternative to the traditional recycling facility. Taking all of that complex, expensive, inflexible engineering of the left-hand side and distilling it down to something mechanically far more simple. Single conveyor, high number of low-cost robot arms in series doing the end-to-end sorting process and turning recycling from an engineering problem to a software problem. And our fully robotic sorting is a step change in cost and performance. By massively simplifying the complexity of the mechanical elements of the system, we can bring the CapEx down by up to 10x and the OpEx by up to 5x. We can deploy new sorting capacity instantly, as opposed to the 2 to 3 year, £50 million facility builds that we have today. And critically, we can respond in real time in the software to changes in the input waste composition and changes in the downstream material demand. But really, we're part of a wider robotics revolution that's coming to all industries, where massive cost reductions in the hardware and advances in AI in the software have unlocked completely new approaches to existing problems. And there's never been a better time than right now to change the waste system. So all waste managers are facing acute cost, performance, and labor pressures. Coupled with that, we've got historic policy intervention in the UK and the EU, and aging of facilities, meaning that waste managers need a complete overhaul of their infrastructure in the coming years as it is. We also have the fact that waste managers who understand that robotics and AI are the future of recycling have now seen firsthand that they don't integrate well into traditional recycling facilities as a retrofit. Existing applications were niche, bespoke retrofits around the edges of facilities that never generated real economic results. What waste managers now understand is that they need a completely new system that's actually built around robotics and AI. And they've been looking for someone to build it for.
Thanks, Johnny. Hello, everyone. So, Johnny, if we could take a look at the video. So this is our R&D system in action. You'll see 3 robot arms working there, sorting waste into different categories. And we're using this to develop our vision system to get more and more accurate, and also gradually working up through throughput. So where we want to take that next is take that R&D system and put it in one of these mobile picking stations over here and deploy it to a real waste site where it can sort real waste. We'll be doing that for about 6 months, escalating and improving throughput and also accuracy and robustness, generating revenue as it goes. And to do that, we're looking to raise 400K. We've got half of that already committed from Carbon13 and from One Planet Capital. Once we've done that MVP stage, we'll then seek a pre-seed to roll out 5 units towards the end of the, into next year. And that will put us on the path to very rapid revenue growth. So why we're doing this is obviously each extra ton of waste that can be recycled saves about 1.6 tons of CO2. That's a combination of the emissions from disposal of waste, but also saving on generating and extracting virgin materials. So with TERASORT, if we can fundamentally make recycling cheaper than landfill or incineration, then we have the opportunity to have a big impact, 29 million tons of CO2 a year by 2035. And just finally, this is a very remote and pristine location in Iceland that I visited a couple of times. And that little dot in the distance, believe it or not, is a recycling collection point. And when I was there last summer, it kind of really brought home to me that obviously the importance of collecting waste, keep it out of the wider environment, but also that we need to really do everything we can to recycle and reuse it to the max. And that's our mission at TERASORT. Thank you very much.
We have questions.
All right. So first question is, what's the capacity of commercial scale facility per annum? And then second question, what's the IP of the technology? How easy it is for existing companies who sort waste to simply replicate it within their budgets?
Yeah, so in terms of capacity, so target capacity for a commercial unit, around about 10,000 tons of recycling per year. So that's equivalent to, I guess, a large, in the UK county level facility, but a large facility being about 5 to 10 of these shipping container sized units. So significantly lower footprint and density of sorting, but that's about the comparison. And in terms of replicating, and I think, as I mentioned, the existing waste robotics applications have been retrofits into the traditional process. So it's more single arm looking at, okay, in a traditional facility, about 10% of the job is still done by a person. Can I replace that person with a robot? And when you do that, when you try and just replicate what a person does, A, you're only working around the edges, but B, you're trying to replicate a very complicated task that a person does. A person is a very good waste picker. And so you get locked into a very expensive set of hardware, and you get locked into you're basically forced your hand into a certain way of picking. It's normally using vacuum to pick stuff up, which even with the best engineering and the best equipment is something that that item gets dropped a lot of the time. So it loses all of your kind of accuracy and performance. I think really the magic comes when you control the overall process and you can simplify what the sorting robot does. So it's about combining how you input the waste, how you prepare it, how you feed it through the system in order to simplify what the sort process that happens, make that sort process as accurate as possible when you've detected an item, and make sure that you're getting that kind of accuracy. You can work around a much lower cost set of hardware, which is what you need to do to get the unit economics that we're describing. So for us, IP, yes, we're developing each item of the system. We have our own vision model. We have our own robotics to do the sorting process. We have our own robotics and mechanical elements to prepare the waste. But as I kind of mentioned, the magic comes when you put it all together as a combined process. And that is a fundamentally new approach. Sets us up in a platform today for massive improvements, but it also sets us up on a platform to incrementally add more and more innovations on top. So dealing with more complicated waste streams, opening bags, pulling items apart, more advanced robotics. So in terms of IP, it's kind of that overall process, combining all of the elements of which we're developing ourselves, but also very quickly layering on optimizations on top as we can go take the efficiency up.
One more question.
Excuse me, maybe I missed it in your pitch, but I'm curious about the impact of your solution, maybe not the impact, but the footprint of the system you need to build. And do you expect it to break even kind of any soon?
Yeah, so footprint-wise, I mean, you can think of the housing for a single unit as essentially shipping container sized. So 10 to 20 robot arms inside, in the first instance, single conveyor through it, sorting waste, mixed recycling taken as a direct input on that conveyor, sorted off by each of the sorting robots. And so, as I mentioned, kind of a large 50 million pound facility, which covers at the moment large footprint, kind of, I guess, football pitch size footprint, can be brought down to the footprint of 5 to 10 containers. And the reason you can bring the footprint down is because we're reducing the complexity of the process. The existing sorting process has kind of 30 steps. It has a rabbit.
I mean, like surface files.
Oh, yeah.
Like, for raw material.
Oh, CO2 wise. So yeah, as Phil mentioned, if the CO2 wise, the average number we've taken off there, kind of 1.6 tons, is for every additional ton of recycling we can cause with our system that wasn't being recycled today, we can save 1.6 tons of CO2. And that's a combination of the virgin material and it's a combination of the reduction in the, I guess, waste processing. The actual direct emissions from the unit are very low because we're using low-cost robotics. We have a small amount of power. We have a small amount of cleaning of the unit, but specific kind of CO2 emissions from the operation of the unit, very small compared to what we're saving. That makes sense.
Okay, thank you very much, Team TERASORT. And by the way, pitching teams, when I come closer and closer, that means that you have to wrap up. So just keep that in mind. So the next team is doing exactly what I was mentioning in the very beginning, tackling a problem, but not selling the sustainability, but finding like a price level that is compatible. And the problem with clean chemicals, for example, is that they are 3.9 times more expensive. What is a...
Carry on. Do you want to do the whole presentation?
Okay. I was told to better shut up now. So welcome to the stage, Chantel and White Lotus Energy.
Can you hear me? Sorry, can you just get it up?
Right. Take your time, but take it quick. I'm running out of. I think a pause can be very impactful, right? So we all just take a deep breath.
This again.
We're getting more and more excited to hear more on White Lotus Energy.
Happens to Madonna as well, don't worry.
I have a hand mic.
No, we're good. We're nearly there. Not going to change Chantal's ears. There we go. Hopefully come down.
So we have 3 more teams to go, including this one. Then we have a tiny break, and I can already tell you, let's make the break tiny, because then we have a great keynote, closing, and then we have network, and we won't distract you with more pitches and keynotes anymore. So you can just chat all day long. But now we're hearing more from Chantel. So another applause, please.
All right. Good afternoon. I'm Chantel Arnaud, the CEO of White Lotus Energies. So we're turning sunlight into clean fuels, starting with methanol. Now, we're going to be targeting the maritime and aviation sectors where green methanol is starting to be adopted to replace fossil fuels. So the good news for these industries is that they can already buy green methanol on the market today. The bad news is this: it's 390% more expensive than fossil fuels. However, these industries don't have a choice. They have to decarbonize. They're getting pressured by consumers. And in the maritime sector, they're also subject to penalties, which increase over time. And they start to get very, very painful. And so when it comes to clean fuels for maritime and aviation, we have a situation where clean fuels mean dirty economics. The reason this is happening is actually very simple. The existing production process on the market today for green methanol has really high costs. It's energy intensive and uses expensive equipment. It's also a multi-step process, which is slow to deploy. Now, these 2 things are combining to mean there's limited scale. So the economics of launching a plant are not very attractive. The end price is very unattractive. Together, we're having a scale issue that's expected to be a 75% supply gap by 2031. So when it comes to giving these sectors what they need, which is affordable green methanol at scale, we cannot fix this process. We can't optimize it and make it what it needs to be. We need an entirely new way of making green methanol. And that is exactly what we're doing at White Lotus Energies. We are supercharging a natural process. We looked at the way that plants use direct sunlight in order to create energy. And we asked ourselves, can we replicate that to make fuels? And the answer is yes. Our process is simple. It all revolves around our catalyst, which is activated by direct light. We then take two abundant feedstocks, carbon dioxide and water. And when we combine these with our catalyst and expose that to direct light, we get green methanol in a single step. We are reinventing energy production. Our pathway is fundamentally different, and with that comes three key benefits. The first is we're using the sun, so that's going to cut our energy costs considerably. In fact, it's 75%. On top of that, we're estimating a 34% cost reduction compared to the existing process. That is just for a pilot site, which is going to be 4,000 tons a year. So that's very small. That means we have a lot more that we can do. Our process is also simple and scalable. So it's single step. That means that we can get to market faster to start to address the supply gap sooner. It's fully circular. We're taking CO2, which is a waste product, and we're turning it into a revenue generating opportunity for industry. Now, from molecules to markets, we have the team to turn this innovation into a business that drives real impact. Our CTO is Dr. Isuru Musakata. He has a PhD in inorganic chemistry. He is an expert in photochemistry. Our COO is Harsh Buddha. He is a chemical engineer. He has 10 years experience, 8 of which he spent at Johnson Matthey, optimizing large-scale chemical production processes. And I'm Chantal Arnaud, our CEO. I have 20 years experience working with high-growth companies with a focus on commercial strategy and execution. So together, we're combining the scientific scaling and commercial expertise to turn this idea into a global impact business. And we're moving very quickly. So we founded the business just last June. By September, we'd been recognized by the UK Department for Transport and Innovate UK by a grant. In October, we completed our first proof of concept. In November, we received funding from Carbon13. And most recently, we made our first methanol. So this was from our catalyst, and you can see the output of that in the picture there. So what you need to know is that the color pink is the winning color. So on the left-hand side is the standard photocatalyst. In the middle is the highest performing rated photocatalyst in academic literature. And on the right-hand side is ours. On our very first try, we performed better than the highest reported performing catalyst. Now, throughout this, we've also been speaking to the market. So we've had over 50 interviews across maritime, chemical, and aviation sectors. And it's very clear they are looking for lower cost green methanol at scale. And as testament to that, we have 6 letters of interest. We've also lined up 5 test partners. So these are going to help us with early stage technical validation. And in the next 90 days, we have 3 milestone targets. So we are going to be launching our pre-seed fundraise in the next couple of weeks. We are just about to start drafting our patent. We have received the prior art search back, and that was all good. So that will be filed by April as we approach TRL4. And most recently, we signed up a new partner to work on a commercial study with us. So this is an organization with 50 years experience in the maritime sector. They're about to launch a carbon capture product for their customer base. But they realize, what are we going to do with the carbon? So together, we're going to explore what a fully circular model will look like if we take carbon captured on board, turn it into methanol, and then use it back in the maritime space. So at White Lotus Energies, our vision is clear. When we talk about energy, we no longer want to say green or clean. It's a world where energy needs no adjectives. If you'd like to support us on this journey, you can book a call with me on the right-hand side or find me after. Thank you.
Thank you very much. Do we have questions?
Thank you for the great pitch. You said in the beginning that green methanol is 390% more expensive than fossil fuels.
Yeah.
How is yours?
How was ours?
How much more expensive than fossil fuels?
So
in percent.
Yeah, so we're at a very early stage. We are at TRL4. So right now we are comparing ourselves to the existing process, which at the pilot stage we're estimating will be 34% cheaper. And we do think we can get that up to 39% cheaper. And then from there, we have 3 levers that we're going to pull on in order to optimize that cost further. So this is going to be a journey. We're not going to come out with the price of fossil fuel, unfortunately. But what we are going to be doing is looking at how we optimize conversion of our catalyst. That's going to be one of the key factors. The second is looking at the inputs, so CO2, and we do use some renewable energy for our distillation process. So how can we get those costs down by either doing power purchase agreements, long-term offtake agreements for CO2, or potentially finding other ways to use waste heat from third-party processes potentially in order to get those costs down further. And the third way is through scale. So as we start to scale up, will the reactor costs start to come down so we can get the cost down even further?
I didn't catch the last phrase, sorry.
Sorry?
In the end, the last part of your last phrase.
Yes, so when we are building the reactors that will use sunlight, as we start to scale those up, that the unit cost per reactor would come down.
Okay. Thank you.
Thank you. There's a company called C1 or Carbon1 Berlin, which is doing something very similar. How do you compare technology-wise? If you know them.
C1 Chemicals.
Yeah.
Yeah, so they are making methanol, but they are using, I believe, wastewater.
Mm-hmm.
So it's a different input because we're using CO2. We're also using direct sunlight. So it's so basically the product is the same, but the process is completely different.
Okay. Thank you.
Okay, one last question.
Do you need to be near the equator or something?
It helps, right? So when we think about modeling this, we're actually doing some modeling around this now. So what does cost look like if I go to Greece versus Chile, or if I go to the Middle East? So it's about looking at the input costs, and solar irradiation is one of them. So more sun helps, but lower renewable energy costs help. Land costs are also a factor. And then the availability of CO2 and the price of that per region will also change.
Wonderful. Thank you very much. Christian Vollmann, the CEO of C1, was our keynote speaker last time, and maybe it makes sense if you speak to each other. I have another great team for you, and I promise I won't tell too much. Do we have chemists in the room here? Okay, some. Do you know how to turn hydrogen and CO2 into cost-competitive acetic acid or other C2 chemicals? No? But Ike does. Welcome to the stage, Ike.
Thank you, Tilly. Okay, let me just check. Do you hear me? Yeah, okay. Fossil carbon built the chemical industry. Captured carbon is going to rebuild it. Hello, I'm Ike, co-founder and CEO of COOLOOP. At COOLOOP, we turn, as Simon told you, carbon dioxide and hydrogen into acetic acid. Zero fossil carbon, cost competitive, and drop in. And this is why it matters. Acetic acid is part of all our lives. Paints, adhesives, PET bottles, aspirin, textiles. Yet it's a $15 billion market, and it's still almost entirely produced from fossil carbon. And it's really hard to decarbonize. Producers are having real difficulty. Carbon costs are rising, Scope 3 pressures mounting, and they lack the technology to really decarbonize without sacrificing margin. But this leaves a gap for fossil-free, cost-competitive, and drop-in acetic acid. And this is the gap which COOLOOP is going to help in. So COOLOOP's solution is structurally simpler. Traditional acetic acid production is multi-step, it's energy intensive, and it's complex. COOLOOP's solution is simpler. We have a single-step reactor which is enabled by our catalyst platform that converts captured carbon dioxide and hydrogen directly to acetic acid with zero fossil carbon. Simpler plant means lower capex, and it also means it's easier to deploy. The other thing is that we're not a one product bet. The same catalyst platform can be used to make other molecules like ethanol and other C2 chemistry. And we've made a lot of progress over the last 6 months. We have catalyst validated. We're on the way to optimizing that catalyst. We have IP for acetic acid, which has been filed, and we're licensing that from Monash University. And we're working on new IP for ethanol, which we'll file this year. And who are our customers? They're large emitters of carbon dioxide, bioethanol producers, industrial emitters, biogas operators. Now, previously, the conversation was, how on earth are we going to decarbonize? But now the conversation is, how are we going to convert that byproduct stream into new product revenues? We've changed the conversation. And the business model that we're going to use is asset light, it's capital efficient, it's license fees up front, it's royalties on product sales, catalyst sales, and technical services. And we're proud that there's a significant carbon impact to what we're doing. For each ton of acetic acid that we produce, we save or we consume over 1 ton of carbon dioxide. But in addition, we avoid the production of 1 ton of carbon dioxide from fossil methanol that's used in traditional acetic acid production. So that's 2 tons of carbon dioxide saved for a ton of acetic acid. And that leads to a significant impact. And we're forecasting almost 17 million tons by 2038. There's an economic impact as well, which is important. And I'll mention that. We can achieve cost parity with incumbent producers at hydrogen prices of between $2 and $3 per kilo. So we're working with world-class partners who can provide us with lab facilities, pilot facilities as well, in-kind support from technical staff and equipment. I want to mention one partner in particular, Godavari, a leading Indian bioethanol producer. So with them, we have a demonstration partnership we're finalizing to start mid this year. But importantly, that includes a pathway for Godavari to build a reference plant subject to technical milestones being achieved. So that's another way in which we're de-risking our roadmap. So we've had strong engagement from industry. You may recognize some of these names. Chemical distributors, industrials, bioethanol and biogas operators. Now we've got a number of LOIs, as you can see, and there's a lot more interest than is shown on here, but this is something we can discuss later. We're scaling rapidly. We have a structured approach though. So the focus this year is about bankable performance data, and it's about extending our IP portfolio to include ethanol. And then in 2027, the focus is pilot readiness. It's about embedding this Godavari pilot project such that we can really move on from there. We're raising £1 million, and we've already got 150 committed thanks to Carbon13. And we have advanced diligence for another 350,000, and so there's 500,000 that's remaining, but we're keen to talk to investors about working with us. So how are we going to use the funds? We're going to really work on the uncertainties that matter: catalyst stability, activity, process validation, and operability, and pilot design readiness. So we want our customers to build with confidence. And this is the team that's going to deliver on our plans. I've had 20 years experience in chemical manufacturing at BP, INEOS, and Synthomer. So at Synthomer, I ran a business in Europe. I've experienced the problem and I've left with the intention of really making a difference there. My co-founder, Dr. Raj Lakshman, he's the co-inventor of our technology out of Monash University. And then we have, in addition, a very strong set of advisors from world-class catalysis to deep tech commercialization. And they can help make sure that we execute with discipline. So I'll leave you with a final thought. Fossil carbon built the chemical industry. Captured carbon is going to rebuild it. And we hope that you come along on the journey with us.
Thank you, Ike. Thank you. We've time for 2 questions. There's one in the back, and now I see more hands. Jack, you've got work to do.
I make it 2 questions then, but I make it very short. First question is, you store CO2 for time in the biomethanol then, but only for time, because if you use it, if you want to get the energy from it, you have to burn it, and then you release these CO2 again in the atmosphere. So it's not really a long-time storage solution. The other thing is, how do you use the energy that is the chemical energy that is in the methanol? You burn it, there are machines to operate it, classical machines, car engines, ships, planes, whatever.
Okay, so maybe I can take the first part of that question. So I think you're right that in terms of how acetic acid is used in downstream activities, that may go into applications which are more consumer applications, and so the life cycle may be shorter than permanent. And so we've done analysis on that, and it essentially about 50% of the derivatives of acetic acid go into solutions which we consider not to be permanent, right? So we have considered that in our analysis, but I think that essentially what we're saying is that aside from that, there's very significant carbon impact to be had by going down this road. The second part is on the fuel. So when we make ethanol, I think you're right that one of the major applications for that is a fuel, and it's a fuel at the moment, right? In petrol. There's also been recently the first ethanol to SAF, to sustainable aviation fuel, and so you're right. There is that issue, that limitation on the permanence of the use of carbon, but I think what we're doing is we're making the process of producing this a lot better anyway, right? And so there is a very significant advantage to be had.
Great, thanks. Maybe follow-up questions on the impact case can be discussed in the networking later. One last question for Ike.
Thank you. As I understand it, your
based on a metal organic framework. And my question would be, what challenge do you see in national lab market, especially with regards to cost and performance degradation of mechanics?
Yeah. So just real quick, because I think the mic didn't work anymore for the live stream. The question was on MOF, so metal organic frameworks, and what it takes to bring that back from the lab to the market, basically. Okay. And the performance degradation over time.
So I think I mentioned in discussing the roadmap that we're focusing on this particular risk, and so working on really improving the durability, so the stability of catalysts. And in terms of the manufacture, this is also a focus of what we're looking at. We're working with Deeside University to really focus on that. So yes, this is the major risk that we face. We're focusing on that now. This is the major focus, and I think we're working with the right people in order to solve this problem.
Thank you very much. last but not least, our last pitch for today, and that is a problem that sits close to my heart. We're talking about peatlands, and I was growing up next to peatland. Basically, both of my grandparents lived next to peatlands, which was quite challenging for when they build their homes because the ground is not very stable. But there was also like a peat cutting factory like next door, basically. So and that is already the flip side of the peatlands. Back then, it was a cheap, like similarly to coal, it was a cheap way to turn something into something that you can burn, basically. That is not great because, and I will stop here, because peatlands store twice as much carbon as all forestry on our globe. And we have Tom here to speak more about that.
No, thank you, Simon.
Oh, and Tom, just one addition, because you asked me to say that peat is torf, or more is like the peatland, and what you get from it is torf in German.
Yeah, thank you, Simon. So I'm Tom O'Hare, the founder of GROUSE Fibre, and I was in cohort 6 of Cambridge in the Venture Builder, so we wouldn't be here at all if it wasn't for the support of the Venture Builder. So as Simon said, peat is extracted for burning, but it's also extracted to grow plants in. And our mission at GROUSE Fibre is to help growers transition away from peat in horticulture. So what do we do? How are we doing this? I have some props. So we are extracting protein from waste streams. Looks like this, just a powder, and that's the easy part. The next part of our process, our science, we are a material science company at heart, is we take the protein and we turn it into fibers. So maybe we show you after, but it looks like polyester, like cotton wool, but it's actually 100% protein. And then we're chopping those fibers up to sell as an additive in horticulture to enable growers to transition towards better peat-free substrates. Why do we do this? Why is it important? Well, horticulture isn't just cut flowers and ornamentals. It's your soft fruits, your strawberries, it's your forestry products, it's your citrus, and it's your mushrooms. So this challenge has an impact on what we see in our supermarket shelves here in Germany, in the UK. And the fundamental bedrock of European horticulture is currently peat, as Simon said. Now, the market size in Europe, about 3 billion euros currently, but it's going to quadruple to 2050 as our diets change, as how we grow our products change. There's already a big supply crunch coming into horticulture, and then you texture in the peat ban, which is coming in 2030 into the UK, into Germany, and you've got this real inflection point on growers, and they are genuinely concerned what they will be growing their products in 2030, because professional growers, they've tried peat-free, and if you've been to the garden centre and you've bought some peat-free compost, you might have seen this effect of sort of crumbly, hard to retain moisture product, and our target customers see this as well. So this is a wildflower grower in the north of England, and these cells should be full of seedlings, but because he's using peat-free, he's got maybe what, 20%, 30% germination. So he's losing money in space, in seeds, and in growing media as well. So we are building a scalable, low-cost protein fiber production platform that uses genuine waste streams to create an additive that really adds value to this sector and is a pretty straightforward drop-in. So I'll just go back actually. This is our sort of demo, our lab line. It is in a drafty and cold barn in the UK, but it's capable of producing 100% protein fibers using our, let's say, our chemistry know-how. And we say that these fibers, they are our super additive. So because they have this protein backbone, because they have 16% nitrogen, and because they absorb so much moisture, when you chop them up and add them to the soil, something quite impressive happens. And we say they are supercharging growth. So I'll let you speculate on which cells have our fiber in. But at the trials of the SRUC, we saw massively increased germination, increased yield, and a more structurally robust plug. And the structural element is quite important for growers. They need to be able to handle their products and move them around, and our fibers act as a bit of a binding agent. So we're not just validating in the lab, we have done some on-site trials with customers to find out how they use their product and the challenges they see and the benefits they see. And then we've also got a large formulator supporting a trial at NIAB, which is the National Institute of Agricultural Botany in Cambridge, which will give us some really high quality data. And we've got a small amount of revenue currently that's growing nicely. Now, this is probably the slide I'm proudest of. Not because I'm there, but because of the quality of the team that I've built. So these 4 people that I'm working with, Siobhan, Alice, Dante, and Alex, they could do whatever they want in their respective fields, whether it's chemistry or plant science, but instead they've decided to come and join me on this mission. And I couldn't be more grateful, but also confident that with the skill set here, we can actually deliver what we're saying we're trying to do. And then I just want to roughly finish here. There is a bigger picture, and that is I remain confident that protein fibers will be a material that cuts through different applications from commodity, growing media, insulation, all the way through consumer, and to the very top of the sort of price and volume profile, which is the specialist biomedical. But our focus is on those applications that first really value the functionality and the unique properties of the protein, then see where we might find the adjacencies. So why am I here? A little bit. So we are just about to kick off a pre-seed round. So to date, we've been fueled by angel and accelerator funding from Carbon13 and Shake Climate Change. Now, 2026, we're looking to raise some money to scale the production of our fibers, do some larger format customer trials, and then obviously boost our sales capability. For now, I'll say thank you and come and chat to me if you want us to help us to fix peat-free.
Thank you, Tom. First of all, thank you all for your attention. These were a lot of pitches and not easy to grasp solutions. So thank you very much. Do you have questions for Tom?
On that? That's behind you,
Doug. Could you tell us something about your competition and price competition as well?
Yeah. So we're not the only startup seeing or business seeing an opportunity in the peat ban. So we see a lot of, let's say, competition in other materials to be used as additives. So seaweed extract, starch absorbent polymers, slow release fertilizer. Now, our fiber will probably price similar to those additives, but it's the sort of the texturing of the different performance elements that we hope will be the advantage over someone just adding a powder or a gel to the growing media. It's the fiber that we think is part of the value proposition.
Hi, can you explain why a protein fiber should be good for seeds and car?
Good for what, sorry?
You have displayed the car seed in your pyramid.
Yes.
I'm wondering. So
yeah. So we are relatively unique in that we're taking a low-cost protein and building from the bottom up. Some of our other technology competitors who are working on protein fibers are doing more designer proteins. So that's proteins grown from E. coli or from yeast that they are using to try and replace polyester with or nylon. So they're trying to create high strength, high functionality protein fibers to go into those more consumer applications. My sort of tactic is to start with something relatively simple, with a low cost of quality that enables us to scale, and then hopefully build and texture in the performance as we learn more about our proteins.
Can you follow up a bit on your background, maybe?
Yes, was that you, Michael? Yeah, so my background is not horticulture. So I was previously in NEREIRA's future team. I've worked in sportswear and automotive. So I've worked on collagen-based ingredients for the automotive sector. So I appreciate why there is an interest in protein as a building block for these applications.
Hey, thank you very much, Tom.
Thanks, everyone.
We have a short break now, and I really would ask you to make it short, because afterwards we have a great keynote from Pina Schlums from Siemens, sustainability lead and industrial AI thought leader. So I'm very excited to hear more and hear your keynote. And then we do the closing and have networking afterwards. So please grab a drink and come back in 5 to 10 minutes maximum. Okay? Thank you very much.
Hey.
Yeah. Please sit down. We would like to start with the keynote. You're doing well. Thank you for sitting.
Okay.
Thank you, Michael.
So I'm just going to go around your ear, actually.
I know. The networking and the chatting is the main part. That is probably next to the pitch is the reason why you're here. And we'll definitely have more time to do so. But now we have an exciting keynote.
Sorry.
And I hope that you're ready over there in the next 30 seconds. Because
Yeah, all good. I am live.
Carbon13 folk, help me out. By the way, if we do that, it means stop speaking, raise your hand so that other people can see that someone wants to say something. It works pretty well when we kick off with 80 people in the room. It's always a very vibrant atmosphere.
That front.
And you do, I do it completely wrong. I have my hand raised and I keep talking. That is forbidden. All right. So I make it quick. There is much better use for AI than generating stupid jokes on Donald Trump. And especially if we're thinking about industrial AI, it has real consequences. And before you implement AI solutions into your industrial processes, I think you better think twice. And you think about consequences and you think about the data that is necessary to get good results in the end. And without further ado, I'm looking to the side. I think there is a bit more further ado.
Good. Okay.
Hand over to Pina. Pina, thank you very much for being here.
Thank you so much for having me. Yes, thank you so much. And actually, I just want to first say that so many inspiring talks and pitches that I've seen today already. Thank you all so much for the teams. It's very uplifting and spiriting to see that so many ideas are coming in so many different industries that we had of today. Yes, I am currently at Siemens in the software division. So just for context, yes, as Siemens said, I'm going to talk about all things AI and especially industrial AI that is not about creating jokes around Trump, but actually creating positive impact, which is quick hands here up. Who says that the climate impact of AI can actually be positive? Oh, wow, that's much more than I would have imagined. Well, then let me show you in a minute a little bit of some concrete examples that we are working on. And but first, just a little bit of context to me. Background in industrial engineering, have been in R&D organizations for a number of years and have now been building up the sustainability domain within Siemens software for the last 4 years already. So yes, let me talk about what that has led to. I'm afraid I'm losing this one here. But
I'm going to give you the handheld. It's time to do your sing-along.
my sing-along.
Yeah, I'm going to
Okay,
take it off. I'm sorry.
all good. We're flexible. Oh,
I'm going to switch this one off. Okay, you're going for the...
I'm going for this one. All right, great. So let us start off with looking at what is the state of industry today. And I want to talk about how we can actually supercharge, and I love that the word has come up in many of your pitches already today. So I'm going to throw in a little, how can we use industrial AI in the race to net zero? what is the status quo from a industrial corporate perspective when we're looking at it? What is the challenge and how can industrial AI be a solution to it? So a lot of the conversations that I've been having, both internally, frankly, but also with external companies as well, is that this conversation starts with that first conversation around, okay, how can we reduce our footprint in time, right? And that time component is really the critical aspect here, especially when we're talking about big industrial corporates, right? And we've seen a lot of the maritime big tankers already today. And I mean, we operate like with the momentum of inertia of a maritime tanker. So it is a time challenge just as much as a scaling and operational challenge. And we have to consider that we need to do this in concert with profitability. We want to introduce new programs, new products, but also increase our ongoing business, right? And that's, to be frank, a challenge that is often underestimated, but also the synergies that can be leveraged here are very much also underestimated. So understanding where optimizing and pursuing both sustainability transformation and profitable business can have synergetic effects is actually the sweet spot, and how we can identify that with industrial AI and capture it is what I want to take you through in this part. So what do we face? We understand lots of challenges, not only in terms of what are the criteria that we're optimizing for that we need to take into account, but also concretely, how do they interrelate, right? And those interrelations, those interdependencies between both all sustainability impacts, right? Between profitability, between the business performance of it, but how can we understand from complex industrial value chains how these aspects interrelate and how we can capture the synergy effects to lead to the potential that we want. Now, this is where exactly the AI evolution comes at a very stringent point in time, because of course that is the capability sweet spot of AI, right? It can capture and master those complexities and make them accessible for us, not only in understanding them, but crucially in optimizing for them. Now, that all sounds aloof, right? When we talk about, okay, well, all the big tech players are talking about AI, what it means when we think about and apply this technology in the industrial space, we need to be, it has different demands than the private or consumer space, right? And how that is that it has basically three main components. So industrial grade AI really demands precision in the way that it's trustworthy, in that a way that's accurate and reliable. So the industrial space, the real world that is governed by the laws of physics, really demands that we have technology that allows, and when we think about driving it to industrial engineering, captures scientific reasoning. So again, we apply the technologies to the field that is governed by the laws that govern the real world. Now, whether that's physics, when we apply it to the physical world, we already had great examples that are governed by the laws of chemicals and biology as well today. So that means that the systems and the AI technologies that we have need to be able to understand and apply the context and the laws that govern these worlds to solutions that are designed for problems to solve in those worlds. So now, this all sounds fancy and good. Let me show you some real world examples of that. And the first one is one of my favorites because it shows that we can take complex engineering problems where 80% of the product's impact of complex industrial products is determined and make it super useful. So what you're seeing here is we're taking the gripper of an industrial robot and completely redesigning it from scratch. So what you're seeing here is that we're giving the design software simply the constraints in terms of the design space, so the physical space it has to create the design. We're giving it the loads and force it has to endure, right? The points where it will hook onto the end of the robot's arm and where it will grip something that it'll hold. So what we're doing is the software then creates from a generative design approach a completely new shape, right? And it explores and creates something that really mimics biology. And I think that's something that is very creative in a way of its form, right? And we're also applying the convergence of different kinds of technologies. So of course, these kinds of shapes and forms can only be realized with production techniques like additive manufacturing, right? So I think that's a point where what is possible today is really not possible because of one single technology, but actually because of multiple technologies now converging to allowing us to create these solutions that we now have. Now, you'll ask, okay, well, what's the upside of this in terms of environmental impact? Well, this robot gripper, now the actual, just from a weight perspective, we brought it down by 80%. But through that, we were able to reduce the entire weight, not only of the robot gripper, but we were able to downsize the entire robot. Now, intuitively, you can understand that if the gripper at the end is lighter, the operational energy that is used of the robot is down as well. So the overall environmental impact reduction that we were able to achieve is actually close to 90% over the lifetime of one of these robots. And then you can think of, okay, well, we don't have just one robot in these plants, right? We have hundreds of thousands of robots in plants all over the world, right? So the scaling potential is huge. And the upside, again, here is we're not just optimizing for the environmental impacts and the energy efficiency of that, but the costs, of course, come down as well because we use less material, we have resource reduction and energy efficiency of that as well. Now, that's all well and good, and the space and solution space is fairly overseeable, right? But we can actually scale this up into one of the examples that I love because it's from Berlin. It's actually a district that we're completely rebuilding on one of the Siemens grounds to make it really, we're building it in the digital world first, because there we can plan, we can simulate, and we can optimize what not only what it's built for, so how it's going to serve the people who are going to work, who are going to go to school, who are going to study and do research on these grounds, but actually what the environmental impacts are going to be. So all of these, what you're seeing, is not just the building is interior, so basically anything that you can see here as well, the lighting systems down to the chairs, everything is captured in the digital twin of these buildings, but actually the entire district is built in the digital world first, so that the entire, like, the flow of heat and cool internally, but also externally. What happens if the sun shines directly onto the windows? What happens inside? How can we capture that energy and make it useful? So all of that, by capturing it in digital twins, is able to be assessed, analyzed again, and simulated and optimized for both the performance, what we want from how we want to serve this built environment for us, but actually optimizing us for the environmental impact as well. Okay, so talk a lot about what the technologies can do for environmental impacts. Now I want to talk a little bit about, okay, what is the AI technology actually that sits behind that makes that possible? So when we look at the entire flow and creation process of industrial products, and they can have a wide range, what we're looking at, every step of this process can now be captured in the digital world. And by capturing it in the digital world, we can apply AI technologies to it. And they can not only just help us understand what the impacts are, but they can increasingly help us in making decisions in a data-driven way towards sustainable impact. Now, that sounds all and good, but it goes far beyond just analyzing and assessing, okay, quantifying, this is the product carbon footprint of set step in the value chain, but actually going beyond and creating not only suggestions, but we're at a point in time where we can actually deploy agents that create completely new products in the design constraints that we give them, with the contextual understanding in the world that they live in. And how we're doing that is actually building an industrial foundation model that works with the modalities that are governed by the industrial space. So you're very familiar with the ChatGPTs and Claudes of the world. Now they are trained on the modalities that govern the consumer space. We're now taking this into the industrial space so that they can work with industrial modalities like drawings, like simulation data as well, and understand that industrial context. So where are we taking this? So co-pilots, I think, were really a thing of the past today already. The space that is most exciting to me personally as well is going into agents, and not just single agents, but having multi-agent architectures that can collaboratively work together to capture more and wider scope of industrial production design and production processes. All right, so long story, but I want to share now a little bit more on how we actually work and collaborate with startups, and also how the 3 ways that we help startups grow, that we collaborate with them, and also allow them to connect to the market that they want to address. And I have 3 examples for each of those. Let me start with GROUSE. So this is a startup that is tackling one of the hardest problems that we probably all have. It's clean energy. So they are building a reactor that is a Tomahawk reactor that is, of course, we understand has complex engineering problems. And to be able to capture all of the intricacies and the complex physics that govern that world of this energy production process, they are applying basically the technology that I just showed you before to solve this problem and build their product. And that is one of the ways how we work with startups, in the way we help them grow. The next way is really a way that I personally also find very inspiring to see always in action, and that is when we collaborate to grow together. Now, this is an example from our mobility space. So as you well know, we have a mobility entity that does all the trains, for instance, that you are probably very familiar with from the German railroads. And the problem that we had here is that our workers kept going out of bounds when they were on site, and created a solution that allowed us to solve that problem in a way with their solution. Now, and this is basically a blueprint of how we collaborate with startups, right? So we use their products to solve problems that we have internally. Another way is an example that I want to share from, again, the digital space, in the way that we connect and build solutions together. So what we like to say is that we're not just building an ecosystem, it's not an ecosystem. So what do we mean by that? As you can see, of course, we have lots of ecosystem partners that we work with. One of them is helping us build what we call the industrial metaverse. Now, I know the term metaverse is a little bit out of fashion, but basically what we mean is capturing in a high fidelity format what governs the physical realities of an industrial site in all its complexities, down to all the details that are relevant to making informed decisions, to make the production processes run in the way that they're supposed to, and mitigate any risks, but also downsides in operation. Now, Rico has developed a solution that is now part of our industrial metaverse technology that helps us capture the realities of sites, right? So we're often faced in a brownfield environment, there's existing assets already there. And we want to capture that to be able to see, okay, how can we optimize this environment to better fit the output that this produces, or equip it for the next generation of products that are supposed to be produced there. So again, here, perfect example, I think, for me, in the way that we collaborate and connect with startups to integrate their solutions into our portfolio to serve a wider market. Okay, well, with these just again highlights of examples in each of these three ways that we work with the startups, I invite you to find out more about our Siemens for Startups program. Also very happy to chat in the networking section that's coming up. So you can go on our website or just talk to me and find out more about what we're doing and how we can grow, collaborate, and connect together. And with that, thank you very much. And I'm very happy to take questions. I see a hand in the back there and one here in the front.
Thank you for the interesting insights. Can you talk a little bit from the customer point of view? Are they already requesting these, let's say, agentic interactions? Because I mean, typically we're doing right now a lot of interviews with industrial production heads, operators, and they're just very much used to their, I call them like boomer dashboards that are kind of like standardized, which are not.
We need another dashboard.
Yeah. So they kind of, I mean, many times you have these operators who run those plants, and they would have to move from a dashboard kind of user experience to an agentic-based interaction. Is there actually a pull from the customer side, or is it more like a nice feature that is like maybe overhyped?
So I think that, yes, there is demand, but it doesn't come in terms of the question being, okay, do you have an agent that can solve this problem? So very much often it's the case that they are only at the stage of being able to comprehend the problem that they have, not knowing that it's agentic capabilities that can solve for it. Right? So this is the bridge that I'm very often in the conversations is the first step of building, right? That understanding that there are now technologies that can solve for the problems that they have, right? So and when we talk about what kind of problems are they having, frankly, in whether that's production or it's actually R&D, it's a workforce that is aging. It's a very common theme of lack of skilled labor in the right areas where they need it, and ripple down effects of that situation, right? So this conversation really starts at, okay, what is the root node of the problem that you're having? And then building from that, where can agentic capabilities be a solution for that specific problem? Because the situation that I see often is AI is being like discussed a lot, but the understanding of where is it actually in the sweet spot of being a solution, that is still I would say in an infancy of understanding in industrial companies.
Thank you so much for the presentation.
I'm very sorry.
Okay.
Ina, thank you very much.
Thank you.
Thank you so much. I was just told that we're running a bit over time, so I'm sorry. But she's going to be around, and we have some more time for questions later. So we have about 2 hours for networking. And I think the thing I wanted to say, so first of all, for those of you that don't know me, I'm Michael, one of the co-founders and managing partners of Carbon13. And this is always an amazing moment for I think, the whole team and us, when this is sort of the ceremonial end of the cohort, and we see how far these amazing founders have brought it. And it's like, it's just heartwarming for me to see how much they've grown up and how far they've come. But also, in the age of AI, and we've heard a lot about AI today, it's really important that we make these human connections. So actually, I wanted to first of all thank all of you and give yourself some applause for being here for so long. Thank you. I mean, I see some of our corporate partners. I see some alumni, which is really great to see you back. I see domain experts, angel investors in our program, investor partners. So yeah, thank you very much for coming here. If you are around and you haven't interacted with us in the program in some way, shape or form, and you would like to, please come and talk to us, come to me and Simon. We would definitely love to have more interactions with all the smart people in the room. And yeah, for me as a founder, one of the most amazing things as being a founder was always when we were able to hire people that actually do things better than ourselves. And yeah, I think we can all agree that Simon made an amazing job today. So let's give him a round of applause. Yeah, and yeah, but all of this wouldn't be anything without the amazing team around Jack, Marina, Haley, that organized all of this. Thank you so much. Who else have I missed? I mean, our entrepreneurs in residence. I think Tom is the only one here today. He's one of the people that helps the founders every other week with sort of advice and helping them with mentorship. And for us, like, it's this kind of community that we're trying to build where people come together. So I hope you have some time to hang out with us, have a drink, have some food. One of the things I wanted to tell you is that something that you can give back to us, if you're an investor and you work with startups at the moment, we're about to kick off an accelerator focused on the EU. So we've been running 5 venture launchpad accelerators over the last 3 years in the UK, and we're launching the first one focused on Germany. So if you're working with any teams that are keen to raise between 1 and 3 million in the next 12 months, we're super keen to speak to them. We're looking for 10 ventures in the climate tech space to come and join our program, kicking off in April. I think as of today, May, thank you, Simon. As of today or tomorrow, the applications will go live, the application page on our website. So yeah, very excited about that. And yeah, we have 2 cohorts currently looking at investments from us, where we will decide in the next few weeks who we invest in, and then in about 6 months we'll have another one of these. So we really hope that you had a good time and you will come back in 6 months again. And yeah, with that, I would just like to invite you to come to do some networking and have some drinks. I'm waiting for something that you'll see in a second will make much more sense. Maybe this doesn't work. But yeah, thank you very much, everybody. Thank you very much for coming today. The drinks will be behind the store. One day we get it so moving that it actually goes up whilst I'm talking. But yeah, thank you very much for coming, and see you later.
So the doors will run here.
Hi, live stream. Thank you for joining us.